Hello viewers, this lesson will be discussing about correlation and regression analysis. Correlation and regression analysis. If you're new to this channel, kindly make sure you subscribe, you like, and you share the videos with some of the other colleagues who are also going to find it helpful. Without wasting much of our time, let's move into what we have in this lesson. Regression and correlation analysis. Regression and correlation analysis. Regression and correlation analysis. So we're talking about regression. Regression is a kind of model, or is a kind of statistical model which is used to derive a relationship between two or more variables. So we have simple regression, we have compound regression, we have mixed regression as well, and so on. And when we're talking about simple regression, that's when the regression is involving two variables. When the regression is involving two variables, that's when it's a simple regression. And under simple regression, you have the linear regression. So in this particular lesson, we will only be touching the aspect of linear regression. Linear regression. And a regression model is said to be linear if it is in the form y equals to ax plus c. If it is in the form y equals to ax plus c. So if your regression model is in the form y equals to ax plus c, then it is a linear regression model. So if we are talking about regression, we also have the aspect of correlation. So regression is the model which we use to derive a relationship between two or more variables. But correlation is a model used to determine the strength of the relationship between the variables. So correlation is the model in which we use to determine the strength of the relationship between those variables. So it is correlation that will let us to know that is there a relationship between them at all. If there is a relationship between them, what is the strength? That is, what is the degree of the relationship between the variables. So that's what regression and correlation analysis is all about. So without wasting much of our time, if in this particular lesson, we will be using two variables y and x. We're dealing with two variables y and x. So if you are asked to determine the regression coefficient of y and x, regression of y and x is represented as byx, which is equals to n summation xy minus summation x multiplied by summation y divided by n summation s squared minus square of summation x. Please take note of those variables. Take note of those symbols. Here you are having what? Summation x all squared. Here you are having what? Summation s squared. So they are not the same thing. They are actually different. So this is the regression of what? Of y on x. So if you are having a regression of y on x and you want to use it to generate the relationship between y and x, then you should be having what? Y minus y bar equals to byx, that is regression of y on x, into x minus x bar. So this is relationship we apply when we are using the regression of y on x. So some questions will ask you to determine the relation of y on x and also the relation of x on y, and also the regression of x on y. So your y bar is your mean, the mean that is the average of y, and your x bar is the average of x, that is the mean of x. So you have to determine the regression of x on y. The regression of y thus is a similar formula: n into summation xy minus summation x times summation y divided by n into summation y squared. Take note of denominator. Denominator will change. Minus square of summation y minus square of summation y. So this is the regression of x on y. And if you apply this formula, then you are having y, you are having x minus x bar equals to the regression of x on y into y minus y bar into y minus y bar. So it is this expression in which you use to generate the relationship that is what? That is linking x and y, or y and x together. And you can now be asked to determine some values of y when x is a certain value, and some value of x when y is a certain value. So that was too much about time. Let's move into the example we have. The example says a study is conducted involving 10 patients to investigate the relationship and effect of patients' age and their blood pressure. So definitely we are having two variables, age and blood pressure, and we are given a table that indicates the age and blood pressure. So the first question says derive the regression model for the patient's age and blood pressure. And the second says use the regression equation to estimate the blood pressure of patients who are 25 and 76 years. From that question too, you can see that you are given age and you have to determine what? Blood pressure. You are given age and you have to determine blood pressure. So we can easily make age our x and blood pressure our y. So automatically the model we need to be applying will be the regression of y on x. You can also use the regression of what? Of x on y. In that situation, you'll be making your age, that is the known value. You'll be making your age your y, and you'll be making your blood pressure your x in that situation. So that's the explanation I have for that aspect. And the last question says you find the correlation coefficient. So the correlation coefficient R, I didn't give us the formula initially. Correlation coefficient R is given by n into summation xy minus summation x times summation y divided by square root of n into summation x squared minus summation minus the square of summation x square root of n into summation y squared minus the square of summation y minus the square of summation y. So our correlation coefficient R is given by this expression. And you should also take note that when R is 0, it means no correlation. When R is plus 1, that's very positive. If it is plus 1, that's perfect negative. If R is approaching 0, that's a weak correlation. If R is approaching 0, that's a weak correlation. But if R is approaching +1, that is a strong positive. And if R is approaching -1, that's a strong negative. So we can have weak positive and we can also have weak negative. So if R is positive and it is approaching 0, that's weak positive. And if R is negative and is approaching 0, that's weak negative. So I've been able to explain everything about correlation. So we can now move to the example. So we're given a table. So let's draw out our table. And we have already decided to make our age X and our blood pressure Y. So I'm going to apply the regression of Y on X. So this is our table, this is solution to that. So we're making age our X. And BP, blood pressure, we are making it our Y. We are making blood pressure our Y. And we are making age our X. So as you can see, here we have 35. The corresponding blood pressure is what? 112. Here we have 40. The corresponding blood pressure is what? Is 128. Here we have 38. The corresponding blood pressure is what? Is 130. Here we have 44. The corresponding blood pressure is 138. Here we have 67. The corresponding blood pressure is what? Is 158. And so on. This is 64. This is 162. This is 59. This is 140. 40. This is 69. This is 175. This is 25. This is 125. 125. And here we have we have 50. Here we have 142. So we can have our totals. This represents our totals. So in this column, as you can see, we are making use of regression of Y on X. And as you can see, our formula is having XY. So we create a column for XY, that is the product of X and Y. We are also having X, summation X, this is X. We are having Y, summation Y, that is Y. We are having X squared, take note. We are having X squared. And this is X, because we are taking square of X and we already have X here. We can use this phrase for our computation of mean, for our mean. So let's begin our analysis. So we need summation X, which is equal to the sum of this. So if we add everything together, what will we be having? We have 35 plus 40 plus 38 plus 44 plus 67 plus 64 plus 59 plus 69 plus 25 plus 50 plus 50. That's 491. This is 491. Our summation X is 491. So we have Y as well, 112 plus 128 plus 130 plus 138 plus 158 plus 162 plus 140 plus 175 plus 125 plus 142 plus 142, that's 1000. Summation y gives us 1410. That's summation y. We also need xy, so we need to multiply these together. So the first is 35 and 112. 5 times 112. 5 times 112, that's 3000. 3920. We have 40 and 128. 40 times 128. 40 times 128. That's 5120. We have 38 times 130. 38 times 130. That's 4940. So we have 44 times 138. 44 times 138. That's 6072. We have 67 times 158. 67 times 158. 67 times 158. That's 10586. We have 64 times 162. 64 times 162. That's 10368. We have 59 times 140. We have 59 times 140. That's 8260. 8260. We have 69 times 175. 69 times 175. That's 12075. 12075. We have 25 times 125. That's 8125. 8125. We have 50 times 142. That's 7100. So we are going to get our x, y. We also have the table for x. Finally, we also want to find our correlation coefficient, and you can see the formula for correlation coefficient is having what? Is having summation y squared. So we also be needing y squared. So we are needing both x squared and y squared. We are needing both x squared and y squared. We are needing y squared for your correlation. So to get our x squared, the first one is 35. That's 35 squared. We have what? We have 1225. 1225. We have 40 squared. That's 1600. We have 38 squared. That's 1444. We have 44 squared. 44 squared. That's 1936. We have 67 squared. 67 squared. That's 4489. 4489. We have 64 squared. That's 4096. 4096. We have 59 squared. 59 squared. That's 3481. 3481. We have 69 squared. 69 squared. That's 4761. 4761. We have 25 squared. That's 625. We have 50 squared. We have 50 squared. That's 2500. 2500. So we have been able to get all our x squared. So we are left with y squared. So let's get our y squared as well. We have 112 squared. 112 squared. This is what? This is 12544. 12544. We have 128 squared. 128 squared. 1636. 384. We have 130 squared, 16900, 138 squared, 138 squared, that's 19044. We have 158 squared, 24964. We have 162 squared, 162 squared, 26244. We have 140 squared, 140 squared, that's 19600, 19600. We have 175 squared, 175 squared, that's 30625, 30625. We have 125 squared, 125 squared, that's 15625, 15625. We have 142 squared as well. This is the last one. We have 20164, 20164. So we have been able to compute our x, y, x squared, y squared, and xy, and xy. So let's determine the summation. We've been using the summation of this as well. So your summation xy, this is going to be the summation x squared, summation x squared, summation x squared. This is going to be summation y squared, summation y squared. So let's add our xy's together. 3920 plus 5.20 plus 4940 plus 6072 plus 10586 plus 10368 plus 8260 plus 12075 plus 3125 plus 7100. So this gives us 71566. 71566. So let's have our solution x squared as well. 1225 plus 1600 plus 1444 plus 1936 plus 4489 plus 4096 plus 3481 plus 4761 plus 625 plus 2500. That gives us 26157. 26157. So let's sum our y squares together. We have 12544 plus 16384 plus 16900 plus 19044 plus 24964 plus 26244 plus 19600 plus 30625 plus 15625 plus 20164. So this gives us 202094. So we have been able to get all our computations, and we know our n, which is in our formula, is what? Is, let's count, 1, number of population, summation 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Our n is 10. Our n is 10. So from here, you can determine our y bar and our x bar. You know you'll be needing x bar and y bar to you calculate your regression of y and x and your correlation. So our x bar, you know, x bar will definitely be summation x divided by n. Summation x divided by n. These are our x and our n is what? Our n is 10. Our n is 10. So our summation x is 400 divided by 10. And obviously now what? Now it's 9.1. 491 divided by 10. Now it's 49.1. So our x bar is going to be what? 49.1. 491 divided by 10. That will be 49.1. So our y bar, which is also summation y divided by n, will definitely be what? Our y bar is 1410 divided by 10. 1410 divided by 10. It will be 141. 141. So our x bar is 49.1 and our y bar is what? Is 141. So we have been able to deal with the table. We've been able to compute all our values. So we can now calculate. We can now compute our regression. We can derive our regression model from those values. You know, the first thing to do is to determine our regression of y on x, and recall our regression of y on x is what? Is n summation xy minus summation x times what? Times summation y over n summation x squared minus summation x squared, all squared. Our n is 10. Summation xy is summation xy is what? 71566. 71566 minus summation x 491 into summation y, that's 1410, and that's 10 into summation x squared. Summation x squared. This x squared, the summation of it, that was 26157. 26157 minus the square of summation x. Summation x, which is 191. Square of it, 191. Square of it. So let's do that very well. That should be giving you 10 into 71566 minus 491 into 1410 divided by 10 into 26157 minus 191 squared. So that's will give us 1.139. 1.1309. So the relation of y and x is giving us 1.139. So recall that y minus y bar is equals to byx, that is the relation of y and x into x minus x bar. This is our regression model. So there we have y minus y bar. We're using y bar to be equal to 141, and we're using our byx, which is what? 1.139 into x minus x bar. We're using our x bar to be what? To be 49.1. So we can take this to this side. Here we have what? We have 1.139x. If you open the bracket with this, and if you open the bracket with this, you'll be having 1.139 times 49.1 times 49.1. So that's going to be giving us minus minus 55.92 minus 55.92. But don't forget we have minus 141 here. It comes to this side, it becomes plus 141. So we can add this together with this. So you can say 141 minus 55.92. So finally we have y equals to 1.139x plus 85.1. Let's say 85.1. And here we can say y is equals to, rounding this up to 2 decimal places, you can say it is equals to 1.14x plus 85.1. So this is going to be our regression model. This is going to be our regression model. So the question also says, using that regression model, estimate blood pressure of patients who are aged 25 and 76. That is, what is y when x is equal to what? Is equal to 25, and when x is equal to what? Is equal to 76. That's what that question is telling you. And when it generates your regression model, so you can now compute. So when x equals 25, y equals 1.14x plus 85.1, and that equals to 1.14 into 25 plus 85.1, and that gives us, we compute that very well, that gives us 1.14 to 25 plus 85.1. That gives us 113.6. So that tells you that the age 25, people age 25 are having blood pressure of 113.6. So when the age, when x is equals to 76, y is equals to 1.14x plus 85.1. And substituting x to this, we have 1.14 into 76 plus 85.1. And that gives us what? 1.14 into, putting that in the calculator, 76 plus 85.1. That's 85.1. That gives us 171.74. 171.74. And that's the answer to that. So finally, we want to determine our correlation R. Determine our correlation R. Our correlation R. That's the third, which is the last question. R. We call that R is what? N into summation xy minus summation x summation y divided by the square root of n summation x squared minus summation x all squared, square root multiplied by the square root of n summation y squared minus the square of summation y. That's the formula for our R. So in this situation, our R will give us n, we have n times summation xy. What is our summation xy? 71566 minus summation x. What is our summation x? Our summation x is 491 into our summation y 1410 divided by the square root of n into summation x squared. Summation x squared is 26157. 26157 minus the square of summation x. Summation x is what? Is 491. The square of 491 squared. Square root of n, that's 10 times summation y squared. Summation y squared is 2094 minus the square of summation y. Summation y is 1410, the square of it. So we can now complete our r. So if we do that very well with our calculator, we have 10 into 71566 minus 491 into 1410 divided by square root of 10 into 26157 minus 191 squared of 10 into 202094 minus 1410 squared. That's very well. That should be giving us 0.9001. 0.9001. So your coefficient of correlation is 0.9001. And what is the interpretation to that? As you can see, this approach plus 1. It approach plus 1. We said that when our correlation coefficient is approaching plus 1, that's a very strong positive relationship. So you can say since R is approaching plus 1, then a strong positive relationship exists between age and blood pressure and BP. You also have to calculate the coefficient of determination R squared. So the coefficient of determination R squared will just be 0.9001 squared. 0.9001 squared, 0.9001 squared, and that's 0.810. You can see the coefficient of determination also approach plus 1, which shows that a very strong positive relationship exists between age and blood pressure, that is between x and y, and that will finally bring us to the end of this particular lesson, which is correlation and regression analysis. If you are new to this channel, kindly make sure you subscribe, you like and share the videos with your other colleagues who are also going to find it helpful. Tutor Bosun is here. Thank you.